PT700 machinery fault and rotor dynamics simulator, designed specifically for mechanical fault diagnosis, teaching and scientific research. It integrates key components including motors, frequency converters, couplings, bearings, rotors, dynamic balancing discs, rotating shafts, multi-stage parallel gearboxes, planetary gearboxes, and magnetic particle brakes to realize simulation of various typical mechanical and motor faults with selectable driving modes. This simulator can reproduce rotor unbalance for dynamic balancing, calibration experiments, as well as motor and coupling misalignment faults. Interchangeable faulty bearings with inner race, outer race, rolling element, cage and composite defects are available to acquire vibration and noise characteristic signals. The parallel gearbox allows convenient replacement of defective gears with missing teeth, broken teeth, abrasion and cracks, and a helical gearbox is provided as an optional accessory. The planetary gearbox supports replacement of faulty ring gears, planet gears and sun gears. The test bench is fitted with a service life prediction module for destructive bearing tests, and 7 motors with distinct faults. And it is equipped with an oil circulation system to conduct vibration characteristic analysis of bearing, gear, and other faults. It enables research on vibration characteristics under different loads, and a built-in heat dissipation system allows long-time continuous operation. The front panel integrates rotational speed control and display functions with a speed range of 0 to 1,750 RPM and 1 RPM precise adjustment via a control knob. The equipment adopts single-phase a C0 to 240 volts power supply at 50/60ths of a hertz, and power plugs compliant with standards of various countries, including China, can be configured. An emergency stop button is installed to cut off the equipment immediately for operational safety. All components are precisely machined with ultra-small tolerances to ensure stable operation. This equipment is applicable to teaching experiments, scientific research, characteristic analysis of fault diagnosis algorithms, and engineering training.